Okay. The Pigeonhole Principle. The Pigeonhole Principle is a useful and intuitive notion which tells us that if we have more objects than containers, we must have at least one container that contains more than one object. To demonstrate, it is useful to imagine a pigeon coop with k number of holes. When there are k plus 1 pigeons, one of the holes must be housing more than one pigeon, because if each hole contains only one pigeon, there would be nowhere for the last pigeon to go. This may be obvious when discussing physical objects and containers, but can sometimes be confusing when applied in other ways. For example, one may pose the question, how many people can be in a room before at least 2 people must have the same birthday? While at first the answer may not be obvious, here the objects are birthdays, which is a calendar day of the year, and the containers are days of the years, of which there are 365. If we are not counting leap years. Viewed in this way, it is obvious that there must be 366 people in a room before at least 2 people have the same birthday. The generalized pigeon principle is an extension of the original principle. However, it applies to situations where the number of objects exceeds a multiple of the number of containers. In this case, n objects are divided into k containers. If n is not a multiple of k, then there must be at least one container with floor of n divided by k plus 1 objects. For example, if we have 16 bikes and 5 garages, there must be at least one garage with 4 bikes. This can be seen when we divide 16 by 5, resulting in 3, with a remainder of 1. The remaining bike must go somewhere, and so one garage has at least 4 bikes. Similarly, if we draw 13 cards and at least 4 must be of the same suit, if you consider that there are 4 suits, the floor function of 13 divided by 4 is 3, plus 1 is 4. Therefore, there must be at least 4 cards of the same suit when 13 cards are drawn. The Pigeonhole Principle and Generalized Pigeonhole Principle are simple but powerful tools in counting many things, including collisions in a hash table, sizes of sets for probabilities, statistical analysis, and actual pigeons in pigeonholes. For more videos on discrete mathematics, please visit www.kno